Dear friends, you already discovered what do we do to pay for Mucky Mansion bills. Today it's a little video about engineering and do-it-yourself. First of all, I would like to share what I have in my workshop and explain what is used for what. As I got many comments about how welding fumes are dangerous, today I use the fumes extractor that is here, and then I will show you what are we going to do following what we did in La Rochelle. First, a little history of helical piles. That's a little helical pile. You see, there's a tip, a helix, and it's galvanized. Well, this one is a really small one, just to show what is it for. So it's like this on the ground, then you screw it in the ground, and when it's screwed, it's screwed. And it's used for supporting buildings, engineering structures, or whatever. Just gives you a solid point to put some load on the ground. Sorry? Foundation. Yes, foundation. It's a foundation technique. You have a lot of foundation techniques. You have piles that can be bored, that can be screwed, or how do you call when you knock? Hammers. No, it's not hammer. There's a special word. I don't remember. Okay. And to people who were asking about PhD and about my joke about PhD, yes, I really have a PhD in mathematical engineering, so I do mathematical modeling of, what do you think? Helical piles. That's it. So, helical piles were invented a long time ago. It was in 1830s by a British engineer who was from Belfast, who was Irish. His name was Alexander Mitchell. Alexander Mitchell was blind. When he was 18, he lost his sight, but it didn't stop him of becoming an engineer and working for the crown. And why did he invent helical piles? They had so many accidents while beating piles in the ground, so he said, screw it. Let's try to do screwing piles. Actually, screw piles or helical piles he invented because it's easier to screw something than to beat. Like hammering a nail, it's more difficult than, for example, screwing a screw. So one day he made a prototype. It was made on some manufacturer that doesn't exist anymore in London. He did a little one that was done by blacksmith because only blacksmith welding was existing this time. And with his son, he went to a little island. He put a screw in the ground and he went back like a week after. And it was still there and very solid. So they said, we will do helical piles. And their first project was the Maplin Sands Lighthouse. Maplin Sands Lighthouse, it's where the Thames goes to the sea. It doesn't exist anymore. But in the world, there are still lighthouses on helical piles. There are many in America, around England, everywhere where you have sandy soils. So it's very good for sand. You go on certain depths. In France, there is still one lighthouse that is in ruins, and I would really like to participate in its restoration where it will be restored. Later we will show you a photo of this lighthouse. It's a lighthouse called Welder Lighthouse, W-A-L-D-E. It's near Calais, in the place called Marc Plage. It's actually a very nice beach there where you have something called Val d'Atlantique. I think it's a lot of block houses built by Germans during World War II. And there's this lighthouse there that is not in use anymore and really like ruins, but it's still staying. It's from 1857, built by the colleague of Alexander Mitchell called Eugenius Birch, who was his partner for his company. And there was a lot of piers, P-I-E-R-S. Yeah, piers still remain in England. Like, for example, some people were talking about Brighton Pier. There's one of old piers that is on helical piles by Alexander Mitchell. And they still exist, they still stay more than 100 years. So, these helical piles, they are different for sure of what was doing Alexander Mitchell. We tried to make a design that is suitable for French grounds. You know, what we adapt is the tip, its length, the angle, the pitch of the helix. its size, its diameter, and basically it's more or less the same principle. Also, I did a big study and published some articles in what happens if you add several helices on the same shaft. We call this a shaft. And so how it will increase the bearing capacity of the pile. Bearing capacity is the capacity of a pile to carry a load. It can carry a compression load, so when it's on the ground you push its compression load, or traction load, or some shear load like this, X, Y. For example, when you have a seismic zone, so it can have an earthquake, you have a lot of X, Y shear loads that will give some acceleration that you will multiply by the mass of the building that is standing on the pile. So the pile is connected to the structure by pile head. Actually, pile heads are just metallic plates that are welded to the piles. Now, let's see what trouble we got in La Rochelle. So in La Rochelle, as you remember, we have our clay, and then we have some stones, limestones. We managed to put a pile that has a good bearing capacity inside this limestone. And actually it's a version 2.0 of helical piles, so it's a ground screw. Something without helix but with a thread. A thread has the same surface as a helix, but it's kind of going not only on one turn, but many. So we managed to screw a pile like this. It was really solid, but we had to do a diameter that is bigger than we were supposed to, because the architect sent us some loads and I did modeling, and so in place of diameter 76.1, it is like 3-inch, we have to use the diameter of 88.9 millimeters. So 88.9 millimeters, but we already manufactured pile heads that are square, where the diameter is suitable for 76.1 millimeter. So I need to do something. By the way, what's going on here? Here, what the architect would like to do, they would like to connect somehow a concrete beam. How is done a concrete beam? A reinforced concrete beam for sure. So there's concrete, and inside you have some layers of reinforcement that are just metallic rebars. You have one here, and they are connected by some kind of, what's the right name? It's not frames, it's, I think they call them stirrups, okay. Like something that you use for horse riding. And so, what happens? And by the way, do you know why the concrete is reinforced? If you have a beam that is, for example, staying on some supports, and here you have some load, what will happen? Here it will bend, like this. But here it will stretch. Bending here will stretch the beam. And here in opposite, it will, how do you call it? Like push it together. Compress it, yeah, exactly. So you have traction downstairs, and above you have compression. And somewhere in the middle, you have something where there's no compression, no traction, just nothing. So what we need to do, concrete is very good for compression, but it's not good at all for traction. If you take a concrete beam, you pull it, it will like dismantle immediately. So you need to put something here that will work well on traction, and we don't care about compression. That's why wise people invented reinforcements for concrete. First, they were doing it for concrete pots for flowers, and then they found out that finally they can do it for construction. It was end of 19th century, if I remember well. In France there was a gardener. It wasn't even an engineer who invented it, it was a gardener. Maybe before Romans were doing something because they knew concrete and mortar, but finally, as we know, actually the reinforcements for concrete, it was invented in France by a gardener. Whatever. So we reinforce it somewhere here, just leaving some space so the rebar is inside the concrete, and also for some other forces we will reinforce it maybe here, and depending of how our beam will be subject to loads, we can have like a cross section of the beam. You can see it from this side, view A. It can be something like this. You have a couple of rebars here, couple of rebars here, and here come a stirrup, like this. So we need to connect this kind of beam to our plate. So the plate is placed here. We know that on this side we can have some compression loads on the beam, but also we have seismic loads that will move the beam here and here. So we need to connect somehow this plate to the pile, and it's really close to the ground. Here I'm not even sure it will have 2 centimeters. So we have this. We have a beam that stays on the pile. Here we have a pile head with a hole that is smaller than the pile diameter, and we have a pile that is on the ground, and here we don't have any space to weld it. So the question is how we do. My idea is the following. We will place inside here a little pipe, and already it won't move. And if we weld the pipe by here in the workshop, it will be okay. Now the question is, you know, how to make it stay from the traction forces. The idea is the following. Here we will put a little metallic rebar, like for concrete, and we fill here everything with the concrete. It will be quite cheap because the concrete is quite cheap. We will make a mortar that will go inside our pile, and so like this it will stay. And so we won't use any welding on site. For sure I will verify it by calculation, but actually it's the good solution. So that's what I want to manufacture now. I want to make something that will be our solution. So check this out. For this I will use some materials, like I will take a rebar. To cut the rebar I will get scissors. They're here. Big scissors. I think they call it bolt cutter or something like this. So like this I can cut some parts. I will use my band saw that you already saw in some video. I will use a welding machine, and I will use my fumes extractor that is here. And I would like to talk about welding. The process that we are using, it's called MIG-MAG. What is MIG-MAG? Metal inert gas or metal active gas. So here inside we have a wire. We have a coil of this wire we will show inside the welding machine, and it goes and it melts in contact with the metal. How it does it, like a short circuit that is created. There's a mesh who is connected to the part, and also the torch is giving the wire that goes out. So the wire melts, but the metal who melts, it needs some protection. That's why there's a gas, active gas or inert gas. Actually, we are using active one. It's argon mixed with CO2. Argon is an inert gas, CO2 is an active gas that is going through here, through these holes. And like this, it protects the welding. It has time to freeze, I don't know, kind of to become solid. You can see when you weld, you really see the liquid metal. And it melts the metal around and it penetrates. So a good welder does perfect penetration in all positions. Don't laugh, Sadie, it's true. So, okay, and now I want to show you the machine that we use. Actually, I have two machines here. One is Swedish ESAB and another one is Lincoln Electric. They are both more or less similar but quite different. I will show you Lincoln. So that's the Lincoln Electric machine. It's a welder. I think it's 400 amps or something like this. It's one that is water cooling. So here you have a module for cooling. Here you have the transformator. And here you have a part where everything is happening. So you have metal coil here. You see? There's metal wire that will go to melt. Here there's some program, and we program it in function of the metal and of gas and also diameter of the wire. So I turn it on. So here I am on the program 21. It means that I am welding with 1.2 millimeters wire. I am welding with argon CO2, the bottle that is here, and I am welding steel. When I will push the button on my torch, the wire will go out, you see, like this, and I can cut it. Also, it's a synergic, how do you say, synergic, okay, machine. It means that the machine will adapt its power depending on your welding on the metal. Here I put the speed of the wire and he will adapt the voltage himself. So now I am on synergic tension. I can put it higher, you see, a little minus that goes up, or I can put it below, down the synergic, but it's recommended to use synergic. For sure, depending on thicknesses and depending on the regime how you are welding, you will put it higher or lower, and like this you are welding. It's very basic, it's semi-automatic process, so you just push the button and you guide your welding and the machine does everything by itself. Very easy. People who want to try welding, I really recommend this kind of machines. In aim to show what the welder sees, we will put the camera in a helmet, inside a helmet. So like this you will see what I see when I weld. Okay, I'll give you a nice helmet. This one is ESAB Sentinel. You know, I don't know which one is better actually, because some people, they really prefer 3M, True Color. Me, I have a Wurt, True Color, but really Sentinel is A60. And I really like them. Usually, you see, here you have like a LCD screen. It turns black when you are welding, then it turns transparent when you are not welding. So it reacts to the light. And I will just change the screen, so like this you can see through the clean screen.
Bend down in your screen.
How many fingers? So I did a couple of points, now I will weld all the joint. Okay, so it's done. Here you can see the welding joint. Well, it's not perfect because I was a little bit high on pressure, but it's okay. And it's melted really well. You can see it will not break. So, and now I would like to weld here a little piece of rebar. Just a little piece like this. Okay, so it's solid, it's welded, you see? Well, you see, for sure, you know, a welding like this can carry a lot of tons. So, this will be our little rebar that will go inside the concrete, inside the pile. Let's try this with the pile that is there. The pile there, it's 88.9 millimeters. Here, 76.1. Let's see how do they fit. Actually, they fit perfectly. So, here I won't even have to weld. I will just put this inside the pile and I will pour concrete inside. So, like this, it will stay and I don't even have to put it somehow. It will be perfect, I think. So I just have to do 10 more. I will do this. Now, like this, we are ready for the site. So, some people call it Welder's Bible, another one call it Welder's Kama Sutra. But actually it explains us all the positions that you are using for welding. And when you are passing an exam to be a welder, I passed mine like, I don't know, 3 years ago in a special controlled body, and I have to pass again this year in March or something. So you do some weldings, then they cut it and they check it, or they do it by X-ray to check there's no holes and nothing left. And what I wanted to say also, you know, to fill a hole by welding, usually a welder will say, well, usually welder and the fitter, they work together. One will fit, another will weld, mostly on pipes, you know, in construction we don't have such restrictions, but a welder will say, if I can jump it, I can weld it. And for people who want to see our helical piles in video, in 2021 or 22, I don't remember, there was a movie called Eiffel, where we got contacted to get piles for their decorations. So decorations of the film Eiffel, like Eiffel Tower, you know, about the guy who built the Eiffel Tower. It's on our helical piles. Well, it was on our helical piles because they were dismantled later. It's a really interesting movie. I thought, you know, it starts, Eiffel gets troubles with Paris City Hall because they're not paying him. I got exactly the same situation. So I was thinking they will talk about how he managed to get money. It was my situation. And so finally, it's just a love story. So people who are expecting something about entrepreneurship, it's not a good movie, but people who want to see a love story with Romain Duris, it's quite nice. And the welder's joke for the end. So, do you know the difference between iron and steel? Well, my co-workers don't iron my clothes when I am at lunch break. And now, dear friends, I will have to stop for today. I have 10 more heads like this to manufacture. Sadie will have to go to rest. And me, I will finish my sites because I really have to finish sites, otherwise no money for Mucky Mansion. And so tomorrow you will see Sadie do something, do some, work in Panar. And me, I will be on sites. Maybe you will get some video inclusions from me on sites, but it will be boring because we are boring. We are doing all the time the same thing.
You can show a bit of progression.
Progression,
Or
yes.
at least the end.
Sure, we will share a little bit of progression, and I hope we will finish these sites in 2 days, because really it starts being annoying. It's so complicated. At least, we placed the rest of the piles in downweeks. We touched the depth of 12 meters. Can you imagine? The geotechnical survey was saying 5 to 7 meters, and now we got 12 meters, and the average depth is 10 meters. Can you imagine? That's crazy. Well, it's a swamp, you can expect everything, but I wasn't really expecting this. So, have a good evening or have a good day. See you soon.